Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. We're going to go straight to the part 2 of parallelogram law. So we're going to solve an example here. So it's very important that you watch the previous video as well as take note of the formulas because we're going to apply those formulas here so we can solve. So what I'm going to do, this is going to be a short video. I'm going to just pick one example and I'm going to solve a question here so that we can then apply what we've learned in the previous video. All right. So before I proceed, don't forget to like, share, and subscribe. If you've not clicked notification bell, I don't know what you're doing or what you're waiting for. Please click that so that when I post new videos, you'll be the first person to know. All right. So let's go. Let's pick this example here. So I have an example here. Okay. So we're told that two vectors, okay, we have two vectors P is equal to, we have it 2, 3, and Q equal to 4, 5. Okay? And we're told I have an angle of 60 degrees between them. Okay? We're now told to find the magnitude of the sum to find the magnitude of the sum vector, okay, and direction of the resultant vector P. Okay? So we're told, so now if you look at the key things to know in this formula here, in the question here, is that we have an angle 60 degrees. This is the first vector, and this is the second what? Vector. So we're told to find the angle here, all right? And now we're told the direction of the vector with P. So this is very important. So let us draw this graph. So we're going to be expecting it to look like this. So we're going to have the P on this side, okay? And we have the Q to be the side, okay? So we're told the P is going to be, take this up a bit. So the P is the P is 2 and 3, okay? And the Q is 4 and 5. So remember what I told you? You then have to then finish this up and make it up to a parallelogram. So we have this one here, and we have this one here, all right? So, and the resultant is going to be from this point all the way up here, and that will be the resultant R, okay? So we're going to use parallelogram rule of vector addition formula here. So we're going to use the parallelogram rule. Okay, we're going to use the rule here, okay? And because the R here is going to be equal to P plus Q. So we're using the addition of this. So we're going to find the magnitude of R. So we're looking for the magnitude. So we can then apply the formula for magnitudes for addition. All right, so let's go. So if you remember, I told you the magnitude of R is equal to the square root, going to be P squared plus Q squared Now, because addition plus 2pq cos theta. Now, this is not actually correct because it's not just PQ, it's the magnitude of P and the magnitude of Q. So the most appropriate way to write this, okay, I'm going to write it like this, is going to be the magnitude of P squared, are you seeing it? Plus the magnitude of Q squared plus 2 magnitude of P, magnitude of Q, cos what? Theta, all right? So if you remember, I gave you this formula in the previous video, okay? So you're applying this. And I also told you that to find the magnitude of P is going to be equal to the square root of x square of the magnitude of the x component of P plus square root of the square of the magnitude of the, square of the y component of what? P, all right? And that will give you that. Then also for Q, it's going to be square root of x q squared plus yq squared. Okay? And I'll give you that. So that means you'll have to find R. We have to first find the magnitude of P. Then we'll have to find the magnitude of Q. I already know our theta was 60 degrees. So let's go. So let's find the magnitude of P first. So I'm going to write this down here so that it'll be easy for me to see while solving. So we know that the P is what? 2 and 3, while the Q is equal to what? 4 and 5, right? All right, so that is that. So let's take it up a bit. So to find the magnitude of P now will be equal to the square root of 2 squared plus 3 squared. And that will give me square root of what? 13. Okay? So that will be the answer, square root of 13. Then the magnitude of Q will be equal to the square root of 4 squared plus 5 squared. And that is going to give me what? This is 25 plus 9. So that will give me 5 times 5 is 25. 25 plus 16, that will give me 41, square root of 41. And that is the magnitude of what? Q. So, and also we know the theta from the question to be equal to 60 degrees. So then we can then find the magnitude of R now. So we can now say the magnitude of R is going to be equal to the square root of the magnitude of P, which is square root of 13 squared, plus the magnitude of Q, which is square root of 41 squared, plus we have this to be 2 times the magnitude of P, which is square root of what? 13 times Q is going to be square root of what? 41. Cos theta is what? 60 what? Degrees. Then when you press this in your calculator, it should give you around 8.7 what? 8. All right, good. Now, the second part of the question wanted us to find theta. They said the direction of the vector with P. So that means we're looking for theta here. So we need to be very, very careful. Sometimes they might want you to find theta. They might want you to find the angle of the resultant with P. So it's very important that you have to look out at the terminologies. But in this case, they want you to find what? This angle here, which is what? Theta. And also, I've already given you that already before in the previous video. So I told you that theta is equal to the tan inverse. Let me use another color for this. Let's see what we have. Let's use purple. Okay. So I told you before that theta is equal to the tan inverse of Q sine theta divided by P plus Q cos theta. Okay? And that will give you, we're going to apply that. So we know our Q for what we did, the magnitude of our Q, just to remind ourselves so that when I'm writing it down. So magnitude of Q, we got it to be root 41, okay? And the magnitude of P, we've got it to be root 13, and we had our theta to be 60 degrees, right? Okay, so with that now, I can take that up. So that will now give me equal to the tan inverse of Q, which is what? Root 41 sine 60 degrees divided by P, which is going to be root 13, plus Q, which is root 41 cos 60 degrees. And when you press this in your calculator, the answer you're going to get is 39.17 degrees. So the angle there is 31.17 degrees. So, but you have to be careful, like I always say, if the question is asking to find beta, that is the angle between the resultant and one of the vectors, okay? And that is that for that. All right. So that is it for addition and subtraction of vectors, and that is an example for that. So I found the resultant and I found theta. You can go to the textbook and play around with more, and you can also solve more questions as well. The next video, I'm going to talk about the scalar product of a vector. So make sure you are subscribed and you click notification button so that when I upload the next video on the scalar product on a vector, you'll be the first person to know. All right. So see you soon, and I will see you in the next video.